Dear students, welcome to the online class. In this video, you are going to study about the complex reactions, in that the consecutive reactions. Consecutive reaction is one in which one reactant, before giving the final product, it undergoes the number of stages or number of intermediate compounds, such as a reaction which proceeds from reactants to final product through one or more intermediate compounds or stages, which is known as consecutive reactions. For example, here A is one reactant react to give B. B reacts to give C. Here B is an intermediate, A is reactant and C is the final product. This first stage takes place with rate constant K1 and second stage takes place with rate constant K2. That is, intermediate compound gives products by this way. Okay. Now suppose initial concentrations. Here the initial concentration of A is A, whereas initial concentration of B is 0 and C is 0. At any time t, concentration of A becomes X. Instead of taking the A minus X, we take here the X. And concentration of B is Y and concentration of C is Z. Okay. At any time t, concentration of A is X, concentration of B is Y and concentration of C is Z. It can be explained with the help of a diagram, such as the concentration versus time. Concentration versus time. This is concentration versus time. Suppose this is the concentration of A, that is A. What happens to the concentration of A? Goes on decreasing. Concentration of A goes on decreasing in this way. Okay. Concentration of A goes on decreasing. Then what happens to the concentration of C? As it is a product, it goes on increasing. It goes on increasing in that way. It goes on increasing in this way. Suppose this is concentration of C. As it is a product, it goes on increasing. What about the concentration of B? Initially, it increases and finally it decreases in this way. Suppose this is concentration of B. In that way, concentration of A regularly goes on decreasing, whereas concentration of C regularly goes on increasing, whereas the concentration of B initially goes on increasing and reaches a maximum at this point. Suppose this is T maximum, where the rate of reaction is maximum. Means the rate of reaction means overall the rate of formation of the product, that is maximum at this, that is T maximum. Now about kinetics. Suppose A is a reactant which gives B an intermediate, B gives C which is the final product, and K1 is the rate constant of first stage, K2 is the rate constant of second stage. Concentrations initial. Suppose initial concentration of A is A and initial concentration of B is 0, concentration of C is also 0 initially, because the reaction is concentration at time t. Here concentration of A at a time t, suppose it becomes X, and concentration of B becomes Y, concentration of C becomes Z at time t. Now rate of the reaction rate of the reaction at time t is equal to dx by dt is equal to k1 into x, k1 into x. On rearranging we get dx divided by x equal to kt, k into dt, k into dt. On integration equation 1 we get integration of dx divided by x is equal to integration of k into integration of dt. When t equal to 0, then x equal to a, and when t equal to t, concentration of x equal to x, that is equal to x. Then integration of 1 divided by x equal to ln x, that is a, and x is equal to k into k1 into t, it is 0 to t. Here the concentration of x is decreasing, therefore this is with the negative sign, and minus dx by dt, this is also negative sign, then you are going to get the negative here also, thus you are going to get negative here also. Thus we get on that is equal to minus ln x plus ln a is equal to k1 into t. Suppose this is equation 2. On rearranging equation 2, we get positive numerator, that is ln a divided by x minus ln x is equal to kt, k1 t, or ln x divided by a is equal to minus k1 into t, that is taking the power x divided by a is equal to minus e raised to minus k1 t, or that is x is equal to a e raised to minus k1 t. Suppose this is equation 3 and this is equation 4. Equation 4 gives the concentration of A at any time t. Equation 4 gives concentration of A at time t. Now calculation of concentration of B. Rate of formation of B. Rate of formation of B is equal to, how the B is formed? By this reaction, K1 into concentration of X, that is nothing but K1 into A e raised to minus k1t. Suppose this is equation 5. Then rate of conjugation of B is equal to B is consumed by this step, that is K2 into Y. K2 into Y. Suppose this is 4, this is 6. Then rate of change of concentration of B is equal to D, that is dy divided by dt equal to by this step minus by this step, that is equal to k1 a e raised to minus k1t minus k2 into y. K2 into y. Now suppose this is equation 7. Here the integration of this equation involves higher mathematics. Directly we can write equation y is equal to k1 a divided by k2 minus k1 into e raised to minus k1 t minus e raised to minus k2 t. Suppose this is the expression for the concentration of y. Concentration of C. We know A is equal to x plus y plus z, means total concentration of x plus y plus z is equal to initial concentration of A. We are assuming here 1 molecule of A gives only 1 molecule of B and 1 molecule of B gives only 1 molecule of C. Then we may write z is equal to A minus x minus y. That is equal to A is as it is. Then it is x minus, that is A e raised to minus k1t minus y equal to we got, that is k1a divided by k2 minus k1 into bracket e raised to minus k1t minus e raised to minus k2t. This is the expression for concentrations of Z. We can simplify this. Z equal to, you take A common, A into bracket 1 minus e raised to minus k1t. Then this A is taken common, k1 divided by k2 minus k1 e raised to minus k1t, minus of minus becomes a plus, that is k1 divided by k2 minus k1 e raised to minus K to T. Equation 10 is the expression for equation 10 is the expression for concentration of C at time t.